Hello everyone. So what are we going to do in this video? We are going to practice the AS Physics questions on the topic dynamics, Newton's laws of motion. This is your video number 1 on question number 1. So as I always say, please take a snapshot of the question. It is your actual past paper question on this topic. Take a snapshot of the question and try to attempt this question yourself. Come back, play the video again to look at the working of it as well as to have a look at the mark scheme of it. So here is the first screen of the question. It is a long question split across two screens. This is the second screen of the question. Also at the same time, please do not forget to subscribe to the channel if you think that the channel is useful to you. It is helping you to become more knowledgeable. It is helping you to prepare for your exam. Please do subscribe, and please do not forget to mention your comments about what you feel about the video. If there is any suggestions, please do mention, and if there is something that you liked, please do mention as well. Alright, so this was your question. Let us come to the first screen, and I believe that you have solved the question. You are coming back to the video, you are playing the video again to look at the working. So let us start by understanding the question first. State Newton's first law of motion. Now this is something, it depends in this question. Answering this question is based on your understanding of how to write this definition. What Cambridge expects you to write here. Newton's first law of motion states that, I'm just starting from the term, states that. This is how you write here Newton's first law of motion, and the explanation of it is also given in one of the theory videos. You can go through the theory videos on the Newton's law of motion. So here you have the mark scheme. A body or a mass or an object continues to be at rest or at constant uniform velocity. You can use the term velocity or speed unless acted by a resultant force. So please do practice how to write the Newton's first law of motion, second law of motion, and the third law of motion, because these are the questions which keep coming every year. So they might ask you 1 year first law, the second year they might ask you the third law, and every year they keep asking one or the other laws of motion. Let us come to the second B part. A box slides down a slope as shown here. The angle of the slope is 20 degrees. The box has a mass of 65 kgs. The total resistive force acting on the box is constant as it slides down the slope. So let us mark where the resistive force would be. Where would the resistive force be? Resistive force always acts in the opposite direction of your motion. If the box is moving this way, what is the opposite direction of this way? It is this way. So let us mark the resistive force here. Let me use a contrast pen. This will be your resistive force, which they are calling as R. Now the question says, state the name and the direction of two other forces acting on the box. So one of the forces that you would have, I'm sure, clearly identified when you solve this question yourself would be the weight. So one of the forces would be the weight. You have to name the force and you have to also mention its direction. So you can say weight. What is the direction? Direction is downwards, or you can say vertically downwards. Other force, that's your weight. Is there any other force as well? Yes, the other force would be the reaction force or the thrust or the normal force, as you call it. Let us call it the normal force. Normal force. Why is it called the normal force? Because it is at 90 degrees always with the surface. A normal force is always at 90 degrees with the surface. If you look at the surface here, normal force is always 90 degrees. You can measure the direction as 90 degrees with the surface. Alright, let us tally with the mark scheme as well. So here you have the mark scheme. Weight vertically downwards, normal force, you also call it reaction force or contact force. All three mean the same thing, synonym terms they are. It is perpendicular or normal to the slope. Right, we have mentioned the same thing. It is at 90 degrees with the surface. Right. So this is done. Let us come to the next question. The variation with the time t of the velocity v of the box. It is a velocity time graph. As it moves down, the slope is in this figure. So what is happening? What do you see happening? Just try to have a quick look and try to understand what is happening. The velocity is increasing with every passing time. The velocity was constant at 0. It was not moving for some time. Then it started moving and the velocity is increasing with every passing time. Use the data in this figure to show that the acceleration of the box is 2.6 meters per second. So how do you find the acceleration? You are given a velocity time graph. Think about it. Whenever you have a velocity time graph, the acceleration is the gradient, right? So the acceleration will be same as the gradient. For finding the gradient, you need 2 points. And you need to apply this formula which you know from your coordinate geometry. The formula for the gradient is this for a straight line. So let us find the coordinates of the 2 points, 2 end points. We can take the 2 end points, which looks quite easy. Here the coordinate would be 2. Look at the scale here. So the scale says each of the block is how much? 2 over 10. And how many blocks we are here? 4 blocks times 4. So 0.8. So this coordinate, the coordinate of this point here is 0.8. What is the coordinate of this endpoint? 2 and let us read the graph all the way from this point, 6. 2 and 6. Let us apply the formula. Let us take one of the point as x2, y2, the other point as x1, y1. Input the values in the formula. y2 is 6 minus 0.8 over 2 minus 0. So this whole thing becomes 5.2 over 2. So this is 2.6 meters per second. You have proved that the acceleration of the box is 2.6 meters per second square. Done. Simple and an easy, very straightforward question. So it is one of the easier questions that you can see in your question paper. Calculate the resultant force on the box. What is the formula for the resultant force in terms of the acceleration? It is ma. Why do we use this formula ma? Because we do not know every other force, the magnitude of the force, every other force we do not know on this box. So it doesn't make sense that you add and subtract all the forces to find the resultant force. Doesn't make sense. But you know the acceleration, you know the mass as well. So it is easy to calculate the resultant force. Let us substitute the values. What is the mass? Mass is given here. The mass is 65 times the acceleration is 2.6. When you'll multiply these two numbers, use your calculators now, find the answer and see if you are getting this answer. They have also done the same thing. They have written the formula. Always a good idea to write the formula. Please do not forget it. Multiply the two numbers and you'll get 169. Give yourself 1 mark if your working was correct and if you got the correct answer. Determine the resistive force R on the box. Resistive force. How do you find the resistive force? You know the resultant force, right? One of the forces, the final forces you have calculated. Now you have to find the resistive force. Let us find the resultant force. The resultant force in terms of all the forces acting on the box here. So let us mark all the forces acting on the box. So here you have one of the forces is the weight acting downwards. Alright. And the other force which is given here is the resistive force. This is what you have to find out. So let us find the resultant. Let us find the component of W in this direction, down the slope. What is the component of W down the slope? You know how to find the component of vectors, right? The theory of it is done. W sine 20. That's the component down the slope. What is the component? If you are finding one of the components, you should always find both the components, right? What is the other component? Both the components which make 90 degrees. You should always find all the components of, whenever you're finding one of the components, you should always find the second component. Every force can have two components which are at 90 degrees. So W cos 20 degrees, because this is your 20 degrees. This angle here is 20 degrees. You can use geometry to verify this is 20. Is there any other force? We had identified that there is one more force acting here, which is the normal force. Normal force. Alright. So what is happening here? The forces which are in the same direction, right? You have to find the resultant for them using the normal laws of addition of forces. Because there is no motion in this direction which I am showing with my pointer. Is the box moving this way, which I am showing with my pointer? The box is not moving this way, right? It is not moving perpendicular to the surface. So it means the normal force is cancelling, is equal and opposite to W cos 20 degrees. They are cancelling each other out. They are cancelling. They are equal and opposite. Why? Because there is no motion in this direction. So they have to be equal and opposite. But there is a motion happening down the slope. There is a motion happening down the slope. That means W sine 20 is bigger than R. So this was your one of the components. They were cancelling each other out, so you can ignore it. Do not worry about it. Do not mention it in the question paper also. But I'm just explaining the theory of it. You can ignore it out, right? These two forces. But the motion is happening down the slope. So W sine 20 will be greater than R. You subtract them. You subtract them because they are opposite to find the resultant force. The resultant force would be W sine 20 minus R. And how much is the resultant force? You have already calculated the resultant force here by using the formula for acceleration. It is 169. So 169 is equal to W, the weight you know, is mg. What is mass? Mass is 65 sine 20 minus R. So R would be 169 minus 65 sine 20. Here you'll have to use your calculator to arrive at the answer. Let me use the implied sign here. It is always a good idea to follow the norms of the maths. That's how you proceed, equation by equation. Okay, so what is the answer? They have also done the same thing. Mg sine theta, theta is 20 degrees, which is 218. So resultant force when you use your calculator should be 49 newtons. Am I right in reading the mark scheme? Yes. So this is your mark scheme. Please do read the mark scheme as well to understand what your Cambridge expects you to write in your answer sheets. Alright, so in the next video we'll take up question number 2 on the same topic, so stay connected.